Good evening students. Today we are going to see how a Boolean function can be implemented using multiplexer. You see the given Boolean function is f of p, q, or s is equal to sigma m of 0, 1, 3, 4, 8, 9, 15. Here the number of variables present in the function n is equal to 4 because the variables are p, q, or s. So we need three number of select lines because the number of select lines can be n minus 1. So the three select lines are taken as S2, S1, S0. Now we are going to choose the size of the multiplexer. Usually if we are having n number of input lines, then we can choose 2 power n minus 1 is to 1 multiplexer. Now we are having 4 number of variables in the Boolean function. So the size of the mux chosen will be 8 is to 1. That is 2 power 4 minus 1 is to 1. The first step in the implementation is we have to draw or form an implementation table. So how the implementation table can be formed here is we have to plot the number of total number of minterms for the given function. Since the function is a 4 variable function, there are 16 minterms present here. So we have to arrange all the minterms in 2 rows as from 0 to 7 in the first row and from 8 to 15 in the second row. Then at the topmost we have to write the number of data lines available in the multiplexer. Because we are using 8 is to 1 multiplexer, the number of data lines for this multiplexer are 8. It is from D0 to D7. So here we have to write from D0 to D7. And the one of the input is taken as select line variable here, which is s. So the select line variable is taken as s bar and s. Next we have to circle the minterms which are available in the given Boolean function. So here the available Boolean minterms are 0, 1, 3, 4, 8, 9 and 15. So we have to circle all the minterms which are present in the Boolean function. Next we have to find the value of the data input. So how the data input value is calculated means if we have to consider vertically, then if the two variables in the vertical line are circled, the value should be 1. If two variables are not circled in the vertical line, the value should be 0. And if any one of the variable is circled, that will be taken as S0, S bar or S. You see, in the first column, we are circled the two minterms. So the value is 1. Here also the value is 1. But here you see the two minterms are not circled. So the value which is to be applied to the data line is 0. Here the minterm is circled only in the S row, S bar row. So the value which is to be applied to D3 is S bar. And for D4 is also S bar. Here all the two minterms are not circled, so the value is 0. Here also it is 0. In the last column, the minterm in the S row is circled, so the value to be applied is S. Now these are the values which is to be applied to the data lines. So now we can go for the implementation using 8 is to 1 mux. So draw the 8 is to 1 mux like this. Since it is 8 is to 1 multiplexer, there are 8 data lines from D0 to D7 and only one output line. The number of select lines needed for 8 is to 1 mux is 3 select lines. So it is taken from S0 to S2. Among the 4 variable, we are using S variable for the data input and the remaining 3 variables for select inputs. So P, Q, R can be applied to the select lines from S2 to S0 and S is taken as the input data variable. You see, in the implementation table for D0 and D1, we are applying the value of 1. So here we have to apply logic 1 to D0 and D1. And similarly, refer the implementation table. Here for D2, D5 and D6 we are applying the value 0. So we have to connect D2, D6, D5 and the value to be applied is logic 0. And the value of S is applied to D7 and S bar is applied to D3 and D4. So S is directly connected to D7 and one inverter is connected here. From the output of the inverter, the value S bar is connected to D3 and D4. So finally the output Y is taken here. So this will be the implementation of Boolean function using multiplexer. I hope all you understood the implementation very well. Thank you.